Hello, this is my second lesson on current electricity. This time we're going to talk about resistance. The resistance is the ability of a substance to oppose the flow of charge through it. The resistance of substances varies from one substance to another. A good conductor of electricity has a low resistance and a poor conductor has a high resistance. So what are the factors upon which resistance of a conductor depends? One, the resistance of a conductor depends on its length. The longer the conductor, the greater the resistance. This is because a long conductor has more atoms and therefore it will obstruct the flow of electrons through that conductor, that material. The resistance of a conductor also depends on the cross-sectional area. Resistance is inversely proportional to cross-sectional area. Smaller conductors have got high resistance while large conductors of large cross-sectional area have lower resistance if maintaining other factors constant. Resistance also depends on the nature of the material. Different materials have different resistances. So if you are talking about copper, for example, copper has a low resistance to the flow of current, but again silver has an even lower resistance. So silver has the least resistance to the flow of current, but silver is a very expensive metal, and because of that silver cannot be used in making electrical wires. So copper is usually the preferred metal when making electrical wires. Temperature is a factor that affects resistance. As we shall see, temperature, the higher the temperature, the greater the resistance. So for conductors, resistance increases with increase in temperature. But for certain other materials, the resistance, such as semiconductors, the resistance decreases with increase in temperature. So those are the factors upon which resistance of a conductor depends. Now this device that you see on your screen is called a rheostat. A rheostat is a device which is used in an electrical circuit to vary the current. It may increase the current or decrease it by changing the resistance of the wire in the circuit. So the section of the wire that has arrows on it is the part of that wire that is within the circuit. So at point A, where you see A at the extreme left hand side, the current flows into the rheostat, and then it passes through the slider and goes out. So as the slider is moved along the brass rod, the length of the wire increases and therefore the resistance increases. So by changing resistance of that wire, we are also changing the current flowing through the circuit. So basically that is the reason why rheostats are added to an electrical circuit. What is internal resistance of a cell? Internal resistance refers to the opposition of flow of current within the cell due to its chemical composition. The strength of current obtained from a cell depends on its EMF and on the internal resistance. The higher the internal resistance, the lower the current. And therefore, also the higher the EMF, the greater the current. We will find later, we will describe an equation that relates EMF, internal resistance, and current at a later stage. Now, internal resistance of a lead cell, for example, is very low as compared to the internal resistance of dry cells. So for that reason, the lead cells produce a very high current. I will give you a question, my students, to think about this. A car battery has a voltage of 12 volts. When 8 dry cells are connected in series, they altogether have a voltage of 12 volts. Do you think they can start a car engine? Explain. So that is an assignment. If you have understood what I have explained about internal resistance, try to explain to find out an answer to this question. Now, how can we experimentally determine internal resistance of a cell? In this, we have a circuit diagram here which can be of use in determining the internal resistance of a cell. This diagram already shows a switch that is closed. But before we get to that point of closing the switch, we find the PD across the cell when the switch is open and record that value as the electromotive force of the cell, as explained in the first lesson. Then we close the switch and then record when the resistance R is equivalent to 1 ohm. Repeat the experiment when the resistance R is 2, 3, 4, 5, maybe up to 6 ohms, and then you tabulate your results in this table. You put your results in this table. Now, using the formula R is equal to capital R into E minus V over V, we get the corresponding values of the internal resistance small r. The small r, this formula gives us the internal resistance of a cell. So for each of the resistances, record what the value of small r is, and then find the average value of those values, and that gives you the internal resistance of a cell. Thank you for listening.